I'm hoping that everybody can hear me well. You can type if you do, just to give me some confidence that you can really hear me. Come on, don't be shy. Yes, okay, perfect. Yeah, so welcome to the Making Patterns Show Themselves webinar. My name is Kalin Konstantinov. I'm here on behalf of the University of Craiova. That's a university here in Romania. I'll be your host for the evening, morning, middle of the night. I know that there are people from everywhere right now. So yeah, it's pretty late here in Romania. It's 10 o'clock in the evening. So in case I stop making sense, you can just switch to another presentations. I think there are 3 more presentations that are happening. So anyway, thank you for choosing this one. And yeah, let's have a little bit of fun. Okay, so this is the agenda for today. I'm going to talk a little bit about myself, some background for myself. As I already told you, I'm from the University of Craiova. I'm doing my PhD thesis there. So because of that, I'm going to include some mathematical stuff in my presentation, just to make it seem much more complex and rigorous than it actually is. So it's just for some giving it some fancy view. And then I'm going to go over the 4 scenarios that were advertised. So basically, the first one relates to check-ins that have been posted on Facebook. Then we'll move over to LinkedIn data, data relating to companies, to skills, to endorsements. I'll then move over to a reputation system, a social reputation system that I've built using Neo4j. And finally, we'll go over the way in which I represented social ranking and relationship strengths over Facebook interactions. Yeah, so this is basically my favorite part of the presentation. I get to talk about myself. As I already said, I'm working with Neo4j for about 6 years now. So I started back in 2013. Back then, I was a master's student at the University of Craiova. So I used Neo4j academically for doing my master's thesis. Because the results were so good, we transformed that in a PhD thesis. So I got to continue working with Neo4j. And in the meantime, I also started working in the industry. Right now, I'm a Java consultant, but I also do trainings and consultants based on Neo4j. So while the cases that I'm going to present here have a purely academic background, I am still pretty well connected to the industry at the moment as well. Yeah, this is the t-shirt for tonight. Yeah. Okay, so
oh my
let's
God,
go.
I didn't even realize you were wearing that shirt. That's so great.
Okay, so this is how I'm representing in a scenario that I'm going to go over at some point. This is how I'm representing the social rank of a person on Facebook. So again, this is something that I do. I need to represent my stuff mathematically, but it's really useful because each and every one of this formula gets translated to a Cypher query, and because Cypher is so easy to do, it makes it like very easy for me to go from this to an actual implementation of all of the stuff that you see here. So I'll just go through it like very quickly. For social ranking, you see that this is a sum of weighted terms. So basically what I'm doing in my representation of a social rank for a person on Facebook, I look over the comments and reactions that that person gets and the comments and reactions that that person receives, because in social networks you have a lot of abilities, meaning that on Instagram you follow somebody, they kind of follow you back, so you need to account for those kind of things and balance them out, let's say. I also have stuff like how attractive the posts of a person are, meaning how much other stuff they generate, like shares, comments, reactions, and so on. And also, I'm looking over how enduring a post of a person is, meaning that I'm counting the time from when the first reaction or comment is given till when about the last one is also given, because that means that Facebook, in case of a long post, that means that Facebook is showing that post to the timeline of many persons. So you can imagine that Facebook also has something like that in the background, but probably much more complicated than this. And it's a good indicator that it's something that's worth showing to other persons. Yeah, so disregard that and just think of it that it's purely theoretical. So you cannot apply that for, I don't know, influencing elections in any country or doing anything like that. So you cannot use the influence to actually affect global politics or stuff like that. Okay, so I'll go over the four scenarios that I've used Neo4j so far. So I'm going to go over them chronologically. This is the first application that I wrote back in 2013. It's called Places to Be. It relates to check-ins on Facebook. So back then, I had 10 users authorize my application, and by using 10 tokens, I was able to grab data from over 20K users. Yes, this was before the Cambridge Analytica scandal. Right now, you know that you cannot get that much information from Facebook by using their APIs. But back then, with just 10 users, I was able to grab 7% of all check-ins that were generated in my hometown in a single night using a commodity laptop. So it was really easy to do back then. Unfortunately, it's not anymore. So after having all that data, I said, okay, I want to grab some statistics from it, and let's find out which are the most interesting places in my hometown. The first statistic, an easy one, I just looked over the number of distinct visitors for every place in my town. This was really interesting because I had there were places where the same person had 200 or 300 check-ins in the same place. So you need a way in which you can balance that out in some way. Going a little bit further, I wanted to look over the places where people seem to be returning, meaning that they have at least one check-in in that location. Having at least one check-in would mean that they probably enjoy being in that place. Or in case of this example here, the first place is a place where weddings happen, and maybe you just get dragged in going there multiple times. So yeah. Okay. As we know, stalking your friends on Facebook is generally accepted. It's not creepy at all. So this is what I've done here. Basically, I looked over which are my closest friends, meaning that they are the persons with which I have the most check-ins on Facebook. And I looked over the places where they commonly go, and I've never been before. And I did the top of those places. So these are places where I haven't been, my friends go, and probably it would make sense for me to go there as well. I think this is the last one for the check-in example. Starting from a place that I enjoy, I wanted to find out different places that seem to be similar to the place that I enjoy. So in the Facebook representation, each place has you can define 3 categories for a place, like pub, restaurant, or stuff like that. Because there are only 3 categories that you can define for a place, you only using the number of common categories would leave you with results like here. So I wanted to also have a way in which I can rank between locations that have the same number of common categories. So what I've done here was actually look over the number of common visitors that go both to the place that I enjoy and to the other places. Because the idea was that if a place drags kind of the same crowd, it might be a similar place to the one that I already enjoy. Yeah, so basically the research for this was actually to see if Neo4j was sufficiently fast in order to do all these computations in real time. So for that, back then, in order to have something like that, you would need to build a cluster like so. In this cluster, you'd have a master instance that ran an embedded Neo4j instance where the Java application was also placed. And you would have like multiple slave nodes used for reading data, in front of which you would have like a HA proxy load balancer. This was a long time ago, and the results showed that I was able to simulate more than 200 queries per second on a commodity laptop or using 3 commodity laptops in under 1 second. So the responses were under 1 second. So that showed me that I was able to do these computations in real time. And I also tried that in SQL, and believe me, you're not able to do that in real time on SQL. So basically, that's the first use case. The second one relates to LinkedIn. So for this one, we took a number of profiles for LinkedIn professionals that were employed in the ITC industry sector, and we wanted to see some statistics about them. The reason behind the research was to see how well our graduates are doing. So a year or two after they have graduated, let's see how well they are integrated in the job market. This would be the metagraph. It's pretty close to what you see on LinkedIn. So the data model is quite similar. For the first example, or the first statistic, I just went and looked over the number of employees that each company has in my data set. So while I had a small number of individuals in the data set, this is still a good representation, because all the things are kind of proportional to the real world number of employees that each company has. So it's still a proportion of that. So it's still a good representation. I looked over the amount of time that an employee spends in a company in months, and it was easy to see that companies that had their own product were more able to keep employees from leaving than the ones that are doing software services. I also applied some temporal analysis on this, and yes, it's true. People are beginning to stay less and less within a company. So right now, people are spending less than 36 months within a company, and it seems that it's going further down year after year. The next one shows from which company do people usually leave, and towards which other company they do that. This can be quite interesting when you're trying to invest, let's say, in a company. It might be useful to see the amount of people that are leaving one company, or actually seeing the profile of the people that are leaving a company and joining the other. Perhaps you'll see that a company is losing a large number of senior developers, which might be an indicator that things are not going so well, or they are losing a lot of persons from a certain department, let's say the Java department, and that can as well be a great indicator for something. So this can be valuable for investing, as I said. Okay, this was the distribution of the people that we actually included in the experiment. So these are our graduates from the University of Craiova, from a computers study program. So what we can see here is that most of them have jobs in the IT industry sector. Most of them are technical, and there's a good balance between the seniority and everything like that. So we could say that our program is doing quite good in preparing the students for the actual job market. Some other interesting statistics. These would be the most showcased skills on the people's profiles. Quite interesting. You can see here stuff that doesn't seem right, let's say. I mean, you can see that a lot of people still have Eclipse listed on their profiles, which is very generic, doesn't really mean anything. The same goes for Subversion, which might seem a little bit deprecated, or XML, whatever that means. So there are a lot of students, let's say, or fresh graduates that don't really put the right skills on their profiles, and yeah, this happens. However, when it comes to the most endorsed skills, it seems that the endorsements don't really go towards those skills that are very generic. So at least here they are starting to shape up a little bit, but still we see that things like XML have a lot of endorsements, still have a lot of endorsements. So while this image doesn't show that much, the next one hopefully does. So here we're taking all the companies or the biggest companies, and we're looking over the top 3 most endorsed skills for each company. So here we can figure out that there are companies that do all sorts of things. So the first 3 endorsements don't represent that much, because those companies are doing maybe software services or outsourcing or stuff like that. So people do all sorts of things, but we also have companies that are very specialized, like in doing automotive or e-commerce or financial services and trading, and that can be highlighted simply by looking at the endorsements of their employees. Also, keep in mind that those employees, sorry about that, keep in mind that those employees have those endorsements for those employees don't have a timestamp attached to them. So they might have come before those employees actually got employed to these companies. This is quite interesting because you can see, for instance, here signals like companies that are starting to invest in blockchain or stuff like that, which again can be quite interesting in case you want to invest in a company, let's say. That would be one of the first use cases. Okay. Now, the third use case. So for the third use case, okay, this one. So the scenario for this one would be that I have a social reputation engine where I need to actually rank persons or rank their reputation or how trustworthy they are. For instance, this has a great applicability in websites like Amazon that are basically marketplaces where various uh, merchants can sell their products and which can employ bots in order to raise stuff for them. I mean, raise their credibility. Or also can happen on IMDb, where people can start and vote movies that aren't actually that good. That's the reason behind the IMDb system, where the top 250 movies, the ranking for them is computed based on just a fraction of the users. So not all rankings go there because some of the users might not have good intentions. So the idea would be to try and actually figure which are the users that have good intentions and which are the users that don't have good intentions. Okay, so for that, I had to model behavior. So this was based on a simulation. We looked over real data from IMDb or from whatever, and we started to simulate how users behave, and we also started to simulate how malicious users also behave. We had like 4 classes of malicious users or trolls, let's say. Some of them were malicious in the sense that I'm back. Okay, perfect.
All right.
Yeah.
All right. You're back. It's all
Yeah.
good.
Okay, perfect. Yeah. So I was saying that there are 4 classes of malicious users. Uh, Hopefully, I'll wait for a couple of seconds. Huh? Is it okay now? Going once, going twice.
I think it's good.
I feel okay. Okay. Yeah.
Rita. Yeah. Okay.
Okay. Yeah, so as I was saying, there are 4 classes of malicious users that I've included in this experiment. Some of them acted independently, some of them acted by camouflaging behind good transactions, meaning that they acted like good users up to a certain point and then abruptly started acting maliciously. Others simply try to affect the reputation of good users so that you don't no longer know which ones are good and which ones are not. So yeah, coordinated attacks, all sorts of coordinated attacks. So such a system should be able to quickly detect if a user has changed his behavior, penalize him like very much, and also make sure that it's better for a user to become a good user than to start off with a new account. So you have to penalize the new users and allow some time to pass before actually accounting their behavior, because that would mean that they start just creating new accounts every day and that's it. So in our simulation, 9% of the users were trolls, basically. So the idea was to detect them by assigning very low ranks, very low reputation ranks to them. So we can see here that the system successfully identified most of these trolls. Depending on the classes of the malicious users, some of them are harder to detect, like the ones that have a behavior of helping the bad users while also having generally standard behavior. They are harder to catch, but using various formulas and stuff like that, we were able to do that. There are a lot of complex computations involved in doing that. So that's why we chose Neo4j, because we wanted to make sure that we are able to do that in a timely manner. So what we did, this is a simulation on a single machine with a relatively low number of nodes. But what we can see here is that the execution time of the system was a matter of minutes. So this would allow you to run the complex system perhaps at least once a day. Also, you have to keep in mind that for this simulation here, all the computations were always done in full, meaning that I didn't account for deltas. With each of these computation, you could only account for the things that happened since the last computation, and that would make the thing go much faster. But even so, it still worked. It still allowed us to identify those malicious users. Finally, the last example relates to what I have started with the social ranking and the relationship strength of the users. So we took a bunch of data from Facebook and we wanted to have some fun with it. So the first thing that we did was to actually see when the largest numbers of reactions are given over Facebook data. And as you can see, people tend to do that early in the morning when they, drink their coffee at work. It tends to drop a little bit when usually people actually work before lunch break. During the lunch break, it goes up again. People work a little bit again after their lunch, and during the evening commute, it goes up quite a lot. This is the same analysis, but it's done for on a monthly basis. So here you can see the months that have a big holiday, like, I don't know, Easter or Christmas or something like that, or the summer months when you go to the beach and post the beach photos and get a lot of likes. Again, it's quite interesting to see these details. Now going to something a little bit more mathematical. So using all that information, I wanted to compute the social ranking of the users. So this would be my community. A bigger bubble would mean that the person is more influent, and a thicker edge between two persons would mean that those two persons influence each other more. There are a lot of factors that are accounted for. I already talked about the factors for computing the social rank of a user. There are also factors for computing the symmetrical influence between two users. This is how it looks for me. Because I don't really comment a lot on Facebook, comments don't really account for that much. when it comes to how I influence my friends, but reactions and similar tags seem to account for a little bit more than that. Okay, I hope I finished up in about 30 minutes, so that's good. So, Karen, should I answer the questions now? Should I show up the slide with the Hunger Games, or how should I?
Why don't we give people the opportunity to ask questions now, and while they're asking questions, you can put up the slide for the Hunger Games.
Okay.
And if anybody has questions, you could just post them directly in the chat, because it's just easier. We're all here right now. Take advantage of Kellen being here. Thanks for presenting. This was really good.
Yeah, thanks.
You could just show the Hunger Games slide if you want. You don't have to like.
Sure. Yeah.
Right. Cool. Does anybody have any questions? If you need time to write your question out, feel free to use the little hand icon that's next to the smiley face emoji in the message box, because that'll be like, I'm raising my hand. Or it's also kind of like a high five. So here, somebody asked a question about seeing an example.
Okay. So how one looks in Cypher. Let me see if I can pull something. Because I do have that, and it is interesting to show. Let me see if I can if I can find that. Just a moment. Okay, I'll try and share my screen. Let's see if that works. So you should see the webinar page right now. Just write if you do, so I know that it's working.
It's loading. It's loading. Okay, now it's good.
Yeah, okay. Perfect. So this is, for example, I think this is exactly the Cypher query for the formula that I went over at the beginning of my presentation. So it's quite easy to read if you actually look into it. I'm just going over reactions and comments and replies to the comments and friendship relationships and all that. And it's really easy to read, at least for me. But imagine writing something like that in SQL. I mean, I think it would be a nightmare to do that in SQL. So yeah, something like that.
We also have a question in the chat, and we have a question in the Q&A.
Okay.
It's the same. The question is, how do you get access to LinkedIn data?
Well, actually, you don't, and LinkedIn never really allowed you to do that. So we actually had a little trick for that one. All of those persons were our students, and we kindly asked them to export their profiles, and we imported them into Neo4j. That's why we had a quite small number of users. So yeah, doing this kind of analysis is hard, even if you're doing it for academic purposes, especially now with GDPR and Cambridge Analytica and all that. It's like really hard to do that. Would I consider this machine learning? Well, actually not. It's a question that I often get. Is it machine learning? Is it, what is it? It's, for me, it's Cypher. I don't know. I don't know how to call it. I haven't really pinpointed something. Okay, so I have scenarios where, okay, I need to actually have machine learning, the classic scenario of machine learning, but otherwise it's just Cypher for me, and the similarities in terms of graphs and patterns. The best tool to load data into Neo4j, I think all those procedures in APOC do help a lot in case you have CSV files or GraphML files. In our case, when it comes to Facebook data, we used Spring Data Neo4j because we didn't really import data. We had to grab it, transform it, and then put it into Neo4j from the Facebook API. Blast for bioinformatics. Honestly, I don't really know about that, but it's something that I'm going to look after. Anyone else?
Callan, I'm going to give you a high five. It's raising their hand, but it's a high five. See? It's a high five. Does anybody else have any questions before Callan leaves us? Okay. All right. I think that.
Perfect.
Awesome. Oh wait, nope. Adam has a question. We're waiting for you to ask your question. He's gonna. It's with the raising the hand thing gives him a second to.
Yeah.
Oh.
Okay. Yeah, that's an easy question. I like that one.
That's a good question. All right, great. All right. Thank you, guys.
Okay, thanks for joining.
Thank you, Callan. I'm going to end the webinar now. Bye.
Okay. Bye, everybody.